Alright, so today's learning targets are that I can graph a linear function using table values, and I can recognize a horizontal or vertical equation and graph it. Alright, so to do this, to start off, graphing things with just one variable. Okay, remember that all coordinate planes are number lines, or two number lines in one, right? I've got an x-axis and a y-axis. I've got an x number line and a y number line. So when I'm missing one of those variables, it means that I don't have representation for the other one. So it just has to be on one of those lines. But what happens is, so for instance, graphing y equals -5. If we create a table of value for that, one side is x, the other side is y, just like usual. But this tells me that y is equal to -5. So no matter what x is, so whatever I pick, so 1, 0, -1, -2, -3, all of these values for y are going to be -5, no matter what. Okay, so I could pick 100 for x, and the value for y would be -5. So nothing changes there. Every single one of them is -5. So if I graph this on a line, remember starting at 0, each of these is an ordered pair, right? 1, -5, 0, -5, -1, -5, -2, -5, and -3, -5, as if that would change it. But anyway, so I've got 1 so starting at the origin, for this one, we've got 1 down 5. It's right here. I did 0 down 5, -1 down 5. So what's happening? Well, I'm going across in a horizontal line. So no matter what my value for x is, my y value is going to be 5. So if I draw that line in, it is a horizontal line. It should be parallel to the x-axis. It should never touch it, right? Because it's only y values. There are no x values, so it should never ever cross the x-axis. So in this case, whenever I see y equals, it's going to be a horizontal line because I'm only plotting y values. Okay, all of the x values, it doesn't matter what they are, right? And so do a similar process for graphing x equals 6. What this is trying to tell me is that when I plot, or when I put a table of values to this, that all of my x values should be 6, no matter what. It's telling me that x is 6. So I have to put x in here as 6 as many times as necessary, but y can be whatever I want. So -1, 0, 1, 2, 3. Okay, so we graph these just like I did over here. These are all ordered pairs. All right, so I get 6 over 6 and down 1. So 1, 2, 3, 4, 5, 6 down 1. Over 6 down 0, over 6 up 1, over 6 up 2, over 6 up 3. And see how it doesn't really matter what my y value is. It's going to go in a straight line up and down. So x lines are vertical. Okay. So pause the video real quick. I want you guys to try number 3 and number 4. See what lines you come up with for y equals 2 and x equals -3. Alright, so again, if I create a table of values, no matter what my x value is, my y value for y equals 2 is always 2. So I'm just going to plot 3 points, -1, 0, and 1. So x value -1, my y is 2, 0, y is 2, 1, y is 2. So look, if I draw the line through that, the current path is going to be a horizontal line through y equals 2. Right? As for x equals -3, again, that just means that on my t-chart, what you should have had was -3 each time I have an x, and my y values do not matter. So 0, 1, -1, and I'll just do those 3 for brevity. All right, so -3, up 1, -3, not, and then -3, down 1. So straight up and down. Line at -3. All right. So we're going to take graphing by table a little bit further today, because we can graph almost anything by table. Anytime I have y equals something, I can graph that by a table. Okay, and just like before, when I mean choose any x's, I mean choose any x's. Pick whatever you want. Just make sure that there's enough to make a point. Okay, and I always use 0 in the middle because 0 is a nice number. It makes things very, very nice. So I've got 0, and then I'll just go to the left, to the right, -1 plus 1, -2 plus 2. All right, and just like with the solving by table that we did yesterday, I'm going to plug those values in for x. So put the parentheses around x. I'm putting all of those in there. And we're going to see what we get. So I get y is equal to -2 squared. Y is equal to -1 squared. Y is equal to 0 squared. Y is equal to 1 squared. And y is equal to 2 squared. Okay, and when I plug those in, get -2 squared is 4, so y is 4. -1 squared is 1, so y is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So this function looks like it's about to be a little bit interesting. So my points, I've got -2, 4, -1, 1, 0, 0, +1, 1, and 2, 4. These are the ordered pairs that I'm going to plot because they come from over here, right? -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. All right, let's see what happens. So we got -2 over, so start at the origin, back 2, up 4. Oops, went too far there. Okay, and then this one, -1, 1, so back 1, up 1, 0, 0. It's easiest, it's the origin. And then +1, so to the right 1, and up 1. +2, up 4. And remember, if you need to, you can put in the polars. So got x in the positive direction, x in the negative direction, y in the positive direction, y in the negative direction. And what it looks like this is doing is creating a u. So if I draw that in, got this type of graph for x squared. Okay, and we'll do some more with this later on, but for now, you should see that pattern when you plug that in for x squared. Alright, so that's all graphed. We've been doing a lot with absolute values this semester, so I kind of want to take a look at what that looks like when we graph it. Okay, and again, I'm going to choose any x values, but I'm always going to put 0 in there just because I like it. So up -1, -2, +1, +2. It's going to make my life a little bit easier. Okay, so y is equal to the absolute value of -2. Y is equal to the absolute value of -1. Absolute value of 0, y is equal to the absolute value of 1, and y is equal to the absolute value of 2. Remember, with absolute values, it's just the distance away from 0 on the number line, so I make any negative numbers positive, and positive numbers stay the same because their distance is how far away, or the numbers represent how far away they are from the number line, or from 0 on the number line, excuse me. Alright, so y is equal to the absolute value of -2. The answer is 2, right? So my y value for this is 2. The absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2. Alright, so when I plug those in, got the points from x value, -2, 2, -1, 1, 0, 0, and +1, +1, and +2, +2. So let's see how this shakes out on the graph. Okay, so starting at the origin, remember x in the negative direction is to the left, so over 2, up 2, to the left 1, up 1 for -1, 1. 0, 0 is at the origin, 0, 0. 1, 1, so over 1, up 1. 2, 2, over 2, up 2. Alright, and if I draw that in, it looks kind of like a V. So notice that the absolute value graph, for at least this one, everything stayed positive, right? Because we know the absolute value makes everything positive. Okay, remember y positive, x positive, y negative. Alright, so last one. got y is equal to 2 to the x. So I'm going to grab my calculator for this one. So I'm going to do 2 to the blank power. So whatever that power is. And again, I'm going to choose whatever x's I want. Okay, so I'm going to do -2, -1, 0, 1, and 2. Okay, so what does this do? Well, let's plug it in and find out. So I get y is equal to 2 to the -2nd power. Okay, and y is equal to 2 to the -1 power. 2 to the 0. Y is equal to 2 to the 1. And y is equal to 2 to the 2. Okay, if I evaluate these, plug that into my calculator. 2 to the -2 power comes back as 0.25. Okay, so 1/4. 2 to the -1 power comes back as 0.5. 2 to the 0 power comes back as 1. 2 to the 1 power comes back as 2. And 2 to the 2nd power comes back as 4. So I've got 0.25, 0.5, 1, 2, 4. All right, and my ordered pairs, -2, 0.25, -1 is 0.5, 0, 1, 1, 2, and 2, 4. Okay, so plot these. -2, so back 2 up a quarter, so it's about right there. -1 up a half, about right here. I've got 0 up 1, 1 up 2, and then 2 up 4. So this is what we call an exponential function. It's going up faster and faster as we go. So as I want to graph this, what's interesting about these is that no matter what negative number I put in, I'm never going to get a negative y value. So even if I were to plug in -100, 2 to the -100th power is 0.0000 something 5. It's really, really small, but it does not go negative. It does not go below 0. So my graph goes out here all the way, but it never crosses the 0. Alright, so there's no practice for tonight. Just come to class tomorrow with this in hand. Oh, one last thing before we go. These functions are called parent functions. They have nothing done. We do not manipulate the x in any way, shape, or form. So they stay true to what their shape is. So we did not manipulate the x. Alright, so anyway, like I said, no practice for tomorrow. Just make sure you come in ready with this done. We're going to talk about these a little bit more. Alright, have a good night.